Hello everyone. Today we are going to discuss about electrical circuit elements. So this is also prerequisite for the network analysis and synthesis course. Electrical circuit elements. What do you mean by electrical circuit elements? What are the types of elements are there and what is the importance of that? So those topics we'll discuss in this class. So circuit elements can be classified as being either active or passive. In the last video, already I have explained about what do you mean by circuit. It is interconnection of elements, right? So in that we have two types. One is active, another one is passive. Active element means this element is capable of generating energy. Examples: current or voltage sources or generators, etc. Passive element, it is an element that does not generate energy. However, it can either consume or store energy. Examples: resistor, capacitor and inductors. These are the passive elements. The most important active elements are voltage source and current source that generally deliver power to the circuit connected to them. Okay, so voltage and current sources, those are the sources are called active elements. Resistance, capacitance and inductance, these are passive elements. Okay. So again, sources are divided into two types: independent sources, dependent sources. Independent sources, an ideal, we can say an independent source is an active element that provides a specified voltage or current that is completely independent of other circuit elements. For example, if we are saying here independent voltage sources, the symbol of voltage source, it is figure A. It shows constant, or we can say here time varying voltage. That symbol we are using. It is showing a circle inside polarity situation plus and minus. If we are showing only for constant, if we want that like a battery or something, at that time we are showing only figure. So there also we are showing positive, negative. It is not like inside circle or something. So that is a big line, it shows positive, and small line it shows as a negative. That is a positive and negative. So second figure, figure B, it is used for the constant voltage source. Okay. Equivalent representation of ideal independent current sources whose current I of t is maintained under all voltage requirements of attached circuit. Just now we have seen about voltage sources, right? Independent. Similar way here, there we have seen like either circle inside the directions, that is the polarities plus minus, or we can say like big line, small line. That is like a battery. But in the current, we have only one way. We can say here circle inside that only direction. It may be up or down. If it is showing up, it is like a positive value. If it is showing down, we can say it is a negative value. So remaining it is connected to this circuit. So this is the representation of independent current sources. So common voltage and common current source labeling, how it is. If you observe this one figure A, so this is the voltage source. It is connected to the entire circuit, remainder of the circuit. Its circuit It may be consisting of voltage, that is a resistors, capacitors, or depending upon the circuit. If it is a AC, it may consist of or L or R, L, C or RC. If it is only DC at that time, it may connect only the resistors. It may be series connection or parallel connections. Similarly, in the figure B, it is source, it is a current source. Okay, so it is connected to the remainder of the circuit. Again, the circuit has same length. That is, it may be consisting of only a or RL or RC or RLC elements. So again, it is a mixture of series parallel or only series or parallel depending upon the circuit. That is a common usage of voltage and current labeling. Okay. So another source, it is a dependent source, right? So it is also called controlled sources. Okay. So dependent source is an active element whose source quantity is controlled by a voltage or current of another circuit element. Generally, dependent sources are represented by diamond-shaped symbols. You can see here we have two symbols here. That is, figure A, it is showing dependent voltage source, right? So second one, it is a dependent current source, right? So both are diamond shape only. Polarity is plus minus. Here it is a current directions. Generally, these dependent sources are very much useful in the designing of transistors, operational amplifiers, and integrated circuits. Much more in electronics applications. Okay. Now, these dependent or controlled sources are again classified into four types. Okay. We have, that is, four we have. First one is voltage controlled voltage source, current controlled voltage source, current controlled voltage source, current controlled voltage controlled current source, current controlled current source. We have total four dependent sources. Okay, this is the symbol. How it is, because these are the dependent sources, all are represented with the diamond symbol only. There, if the value it is, okay, suppose Vs of t equal to alpha into V of t. That means here, this one it is a controlled by voltage control, but this is the voltage symbol inside the diamond shape value, that is a positive and negative polarity, that is only voltage. In the second one, it is current control. That value it is in terms of current, right? So that is, this value it is Vs of t is equal to beta into I of t. This it is depending upon this. That's why it is a current controlled voltage source. Again, it is a voltage source. Okay, due to polarity. Similarly, we have another two sources, current sources. One is a voltage controlled current source, another one is current controlled current source. Okay, so here in the diamond shape we have arrow. Arrow means it is a direction. When it is showing direction means it is a current source. But this one first figure, that is a third one, here it is a depending upon voltage. That's the reason here voltage controlled current source. Okay, that is Is of t equal to gamma into V of t. Voltage controlled current source. And next one it is current controlled current source. And this Is of t equal to delta into I of t. So both are current sources only, but one is a depending upon, that is a controlled value is voltage, another one is controlled value is current. These are the four dependent or controlled sources. Example, if you are seeing here, Just you can identify. In the following circuits, identify the type of dependent sources. We have two figures here. You can observe. Just I am giving hint here. So we have first figure, if we are seeing one source, that is an active element we have, right? Voltage source. So these are the A, B, C. These values you can see here. It may be resistors, or it may be capacitor, or it may be inductors, depending upon the, because here you are taking, if it is DC, that's the reason you will get only ABC values are resistors. Okay, and this value is diamond shape. Inside polarity is positive, negative. So that means is it voltage or current? So it is a voltage source. So in this voltage source, but it is depending upon which one? Current. Okay, so current controlled voltage source. Now for your understanding, I will show here. Just to see here how it is. Second one, right? So current controlled voltage source 10. Just see the second one again here, because it is like one example of which one, hybrid values. Generally there we are using this type of things many cases. Hybrid applications. You can see here it is the source Vs supply, and again it is the load values. So it may be R1 or 2, whatever the values you are taking depending upon the circuit. And this source, it is a dependent source. Again it is a controlled source only. This source, okay, this source, it is a current source, right? Because it is an arrow showing current source, and the value is 6 I0. So it is depending upon current, right? So whether it is which type of current source here it is a current controlled current source. This one, just you see here, last one, right? So in this way you need to find out type of dependent sources. Now we'll discuss about passive elements. We have three passive elements: resistance, inductance and capacitance, right? Now here we will discuss mainly on resistance in this class. Resistance, resist means what? Oppose. It is oppose, right? Simply based on that word itself you can say the meaning of that. The resistance of an element denotes its ability to resist the flow of electric current. It is measured in ohms. Okay, it is denoted by R, that is a symbol we are taking as a resistance. Generally, how to find this one? The resistance of any material with uniform cross-sectional area A and the length L is inversely proportional to the area and directly proportional to the length. You can say here the resistance is directly proportional to the length and inversely proportional to the area. So rho is directly proportional to L by A. So in the figure, this is the resistance general. So this is the cross-sectional area and this is the length of the resistance. So this one, it is a resistivity that I will tell after few minutes. And this is the circuit symbol. Generally when we are using circuits, right, at that time we are representing in this format. Okay, that is the circuit symbol for resistance. So R is directly proportional to L by A when R is equal to rho into L by A. So that rho, it is called resistivity of the material. Okay, so that is the value. Now actually this resistance was invented by a German physicist, George Simon Ohm. In the name of is in the name of George Simon Ohm. The unit of resistance is named as Ohm. OH. So that is the symbol, right? This is the symbol for the Ohm. Okay, that is resistance. So he is the German physicist. He invented this. A conductor designed to have a specific resistance is called the resistance. When you are talking about this one, electrical circuits, in this way we are representing, this is the symbol, alright? So this is the voltage across this one and current flowing through this one. And if you are taking this one, that is equivalent only. Whatever we are saying here, this is the source, it is connected. These are the fuses generally. How these are connected, now it is a closed one. So current is flowing in this, that is I, and this is the resistance value. Across the resistance, it is the V volts. Okay. So in this way, we have to connect the resistor in the circuit. So already we have discussed the electric circuit. This is also one electric circuit. We have source and we have elements. So that is the active elements and passive element. Okay. Next, already we have discussed about resistance. Based on that, we got one law, that is Ohm's law. It is also useful for the circuits because it states that Ohm's law states that the voltage across a resistor is directly proportional to the current flowing through the resistor. Basically, it is a V is directly proportional to the I. Okay, if it is in terms of time, that is V of t is equal to directly proportional to I of t. When it is equating, V of t equal to R into I, where R is resistance of that resistor. Okay, that is the resistance. Okay, if it is only DC, V equal to, we can write capital V equal to R into I. Same, we can represent again, we can rewrite I equal to what? V over, right? V over R, V of t by. If it is ISC, at that time you are taking, if it is depending upon the sources. If it is in terms of time, at that time you have to take V of t. If it is only fixed value or constant, you need to take only V by R. Okay. That is. So same thing you can represent I of t equal to G into V. What is G here? It is a conductance. Okay. Instantaneous power. Already we know power, right? What is power? Power, it is nothing but product of voltage and current, right? So last video I already explained about how to find out that what is the unit of that. So V into pi. Where, so if you are substituting from these two expressions, if you are substituting V equal to R into IT, what you will get? So P of t equal to I square of t into R, right? This one, last one. Okay. If you are substituting this expression in this, I of t equal to V. So what you will get here? V square of t by R. This is the expression you get. So these are three different equations for power. This is the standard, right? V into I, V square by R, I square into R. So three laws, that is the three expressions you can use for the power. Resistors, we have two types of resistors, linear and non-linear resistors. You know what I mean by linear. So if it is, already we know that V is directly proportional to the I. This slope, if it is a linear, so that is it is passing through this, right? So this one, it should follow the superposition and also homogeneity. Then it is called linear or linear. And then non-linear, it is not like linear. It is not following the, it is not obeying the rules of superposition and homogeneity. But in our circuit, you can say network analysis and synthesis or electrical circuits, generally we assume that all the resistor values are linear values only. Okay, unless mentioned otherwise. If they are mentioned specifically these values, otherwise you need to take only linear values. Okay, so that is conductance. So what is the conductance? It is represented by Q, right? Symbol is, so conductance is nothing but the reciprocal of the, which one? Here it is resistance only. Okay, G is equal to 1 over R is called conductance of the element and is measured in Siemens or mho also. It is inverse of omega, right? That is mho. Just OHM MHO mho, inverse of that. German inventor Ernst Werner von Siemens was invented this conductance. Conductance is the ability of an element to conduct a current. Simply say here conductance, it is a easily allowing the flow of current. Okay, just note down this one. A device with zero or no resistance has infinite conductance. Suppose, so for example, if resistance value is 0, that means no resistance means 0 value, right? So that value it is having infinite. So already we know G equal to 1 over R, right? If R is 0, G is infinite, right? So that is infinite. A device with infinite resistance, suppose high value of a resistance, at that time conductance is 0 conductance. Now, short and open circuits. We are seeing different types of circuits. We will see in future also. So a device with zero resistance is called short circuit, and a device with zero conductance is called open circuit. For example, we have two figures here, right? Figure A and figure B. So in the first figure, if you observe this one, this is the short. This entire network or circuit remaining may be consisting of all, we can say here, source and passive elements, combination of series, parallel or parallel series. It's a combination, whatever the circuit, entire network has remaining network. And this one is at the nodes, right? We are taking here. So this one, it is a shorted with the wire. In this case, whenever you are shorting here, so that means there is no resistance value. Resistance is 0 in this case. But current flows here, right? Whatever the current it is, this current flows. Generally, when it is short circuit, high current flows. That is only we have taken just now, right? That is. In the second figure, say in the left hand side you have entire network, and here these nodes, simply here it is open. Just to observe here, open. So when it is open, no current flows here. So no current flows over here. It means at that time resistance value is very high, infinite. No current flows, but it has voltage value, that is open circuit voltage. In the figure A, here resistance is 0 and this value voltage also 0 here, but current is there, that is a high value of current. So these are the two short and open circuits. These are very useful for the coming days in our network analysis and synthesis course. We will take few examples here. Okay, how to find out current by given circuit. Here I am not, just we are taking The essential component of a toaster is an electrical element, that is a resistor, that converts electrical energy to heat energy. How much current is drawn by a toaster? With 15 ohms at 110 volts. This is the problem. So here toaster is there. So that is converting electrical energy into heat energy with the help of this resistor. How much current is drawn? That is our object. We need to find the current with the resistance value is given or equal to 15 ohms and V equal to 110 volts. Right? Already we know Ohm's law. From that Ohm's law, we have to take here V equal to IR. This is the fixed value of voltage, right? So V equal to 110 volts. And R is given 15 volts. So from this expression, V equal to IR. So what is I? I equal to V over R. Just substitute 110 by 15. You will get the answer, that is 7.333 amperes. So by using Ohm's law, we can find this. Okay. So now just a quick hint here, you can practice. Determine the power absorbed or supplied by the elements of the following network. Okay. So this is the figure given the circuit or network. So source, it is given 24 and the current is flowing, it is having 2 amperes, and this is the which one resistance you can take, this is the another resistance. So in the series circuit, generally whatever the current flows in this entire circuit is equal. That's the reason here it is shown 2 amps, here also same. Across the first element it is 6 volts, across the second it is 18 volts. Okay, because we don't know value of resistance here, directly they mentioned here the value. We need to find out the power individual values. If you are taking here, so first element voltage is 6 and current is 2. You can use by using that comes based on that we know how to find the power. We have different formulas for that. VI you can use V square by R, but we don't have R here, so you have to use only V into 2. So 6 into 2, 12, and here 18 into 2. Okay, you see here how much we are getting here, 18 into 2, and here 16. Individually you have to find out how much it is absorbed, how much it is supplying. This is the supply voltage and current. Now you can see here 24 into 2, 48, and here 12, and this one it is 36. 36 plus 12, 48. This is in this direction, right? In this direction, and this one it is in this direction. So this equal here. Whatever the absorbed is equal to supply. So this value P1 and this value is, in this way we need to find out the problem. You can practice that. And similarly another problem, it is also for practice purpose. The power absorbed by the 10 kilo ohms resistor in the following circuit is 3.6 milliwatt. Determine the voltage and the current in the circuit. Here also just I am giving here hint. It is a very simple problem, you can try. Source is given V of S and this is the current in this circuit. You need to find this value. These are our objectives. You have to find the value V of S and I with the help of these two, because in the circuit it is given 10 kilo ohms resistor R and power is given 3.6. Already we know from that expression we can find out P equal to which one? We have V into I, you have which one? I square into R or V square by R. Okay. If you are taking P equal to I square into R, I square into R. So you can get the value of current. I equal to what? What you will get? I square into R equal to P, right? I square equal to what? P by R. So I equal to square root of P by R. From that you can find the current. Similarly for the voltage, how to find out power equal to, so V square by R. So Vs equal to square root of P into R. From that expression you can find the voltage also. Okay. Same way you can find here. Given the following network, find R and Vs. Last problem explained how to find out the current and voltage. In this problem, we can find the value of resistance and voltage. Similar, same formulas used here. These are the general formulas. Based on that, you can find the all values. It may be voltage, or it may be current, or it may be resistance. Or if they have given voltage and current, you can find the power also. Okay. Only based on those three expressions you can find any value. They will give two values, you can find the other one. Okay, that is only. Similarly here, it is another practicing problem. Okay, so this one, given the following circuit, find the value of voltage source and power absorbed by resistance. But here they have not given the resistance, but it is given conductance G equal to 50 microsiemens, right? So that is the value. Already we know what is the relation between the Siemens and which one? Ohms, right? So G is given R equal to what? 1 over G, right? So same, just G equal to 1 over R equal to 1 over G. So you know I, you know R. So from that you can find the voltage, you can find the current. If you want to find out only voltage, we will get I into R or I by G. That also same. If you want to find the power, so P equal to I square into R, right? I square by G. That is also you can find the power absorbed by the resistance. Okay. So thank you all. So in the next class we'll discuss some more terms used in the circuits. Okay.